All right, here's our little chapter 6 quiz on solving systems and equations by using matrices. So question 1 said to use row operations, so row echelon form, right? And something we didn't talk about previously is that some textbooks call that process Gaussian elimination. So just something to be aware of, that different mathematicians call things by different names, and that's just another name for this process. Okay, so go ahead and just get rid of all of this. Start fresh. So when we do row echelon form, we are creating an augmented matrix with our coefficients. 1, -2, -1, 4, which are the numbers next to the x's and y's, and then our constants, 3 and -7. Okay, and we want to try and make our matrix into the form of the identity matrix, which would be 1, 0, 0, 1. So to do that, we would need a 0 here, and then a 1 here, and then a 0 there. So we need a 1 here first. That's like the first thing. There's already 1 there, so we're good to go there. So to get our 0, we want to add row 1 and row 2. So we're going to have a new row 2. That will give us our new row 2, and that will give us our 0 in that spot right there. Okay, so I'm just going to add those together. 1 plus -1 is 0. -2 plus 4 is 2. 3 plus -7 is -4. Meanwhile, that first row there is going to stay the same. So 1, -2, 3. Okay, our next goal is to get a 1 here. To do that, we're just going to divide by 2. Now, technically, dividing is not one of our row operation rules. So instead, we usually say we are multiplying by 1/2. Same idea. So divide by 2 or multiply by 1/2. So basically, we're going to get a new row 2. Our new row 2 is going to come from 1/2 times our old row 2. That will give us 0, 1, -2. I just divided everything by 2. And I still have my same first row on the top. Okay, then the last thing we want to accomplish here is we want to get a 0 in this spot right there. So to do that, we're going to get a new row 1 by taking our old row 1 and adding it with 2 times the new row 2. Well, and now it's new row 2. We're moving on. So honestly, what we had written before with the 2 before we divided it out, if we had actually added that before we divided the 2, we would be good to go. But typically, it's good to get the numbers in this order, but you don't always have to. It might have actually been better to get the 0 here first before dividing everything by 2. It's okay. So we're just kind of temporarily undoing what we just did. So that will give us 0 times 2 is 0 plus 1 is 1. 0 times 2 is 2 plus -2 is 0. 2 times -2, sorry, I might have said the wrong thing earlier. 2 times -2 is -4 plus 3 is -1. And then, of course, the row we had previously was this. And so that gives us our answers, -1, -2. Right? So there's that first method. Let's look at the next one, which is Cramer's rule. Cramer's rule is where we use determinants. So we have our main determinant D, which comes from our coefficient matrix. So the coefficient matrix is just the numbers in front of the x's and y's. So you can see I've got these here, I'll just trace back over to get your attention. So 1 next to the x, -2 next to the y, -1 next to the x, and 4 next to the y. And then we do our determinant formula, which is cross multiply 1 times 4. So I've got 1 times 4, which is 4. And then I cross multiply -1 times -2. And we subtract, right? So cross multiply the top left, bottom right, and then subtract the product of the top right, bottom left. So that gives us 1 times 4, which is 4, minus -1 times -2. So 4 minus 2, which is 2. So that's D. Then for determinant x, that means we're going to take our x column from our, I'm going to rewrite this part here to make it easier to follow. So we take the x, the constant values, 3, -7, and we put those into the x column, dx. That's our x column, right? We're replacing those with the constants. Okay, so now we do our determinants again. So 3 times 4 is 12, and -7 times -2 is 14. 12 minus 14 is -2, so there's dx. And then we have this one where we replace the y column with our constants, for our dy value. And then we do our determinant again. So 1 times -7 minus -1 times 3. So we get -7 minus -3, which is the same as -7 plus 3, which is -4. Okay, now that we have those 3 determinants, divide them. So to find x, we take determinant x, which was a -2, and we divide by determinant d, which was 2. So this first one here. And -2 divided by +2 is -1. So there's our x value. And then for y, we plug in dy, which is -4. And again, we're going to divide that by determinant d. So -4 divided by 2 is -2. So our solution set is -1, -2. Same answer that we got in the previous problem, yes? Yeah. Okay, last one is finding the inverse. Go ahead and show you this whole screen and then we'll figure out. I'm going to redo the formula one. So matrix A is 1, -2, -1, 4, still that coefficient matrix. Matrix B is our constant matrix. We start by finding the inverse. So the inverse can be found with our little formula if you want to memorize it, but it's not on your formula sheets, right? So 1 over the determinant times, we trade the positions and we change those to negatives, multiply the determinant through, and we get this as our inverse matrix here at the end. So then we take our inverse matrix A and we multiply it times our constant matrix. So when we multiply, just a reminder how we do that, we take the row times the column. So 2 times 3 is 6, and 1 times -7 is -7. 6 minus 7 is -1. Then we take the bottom row times the columns. So 1/2 times 3 is 3/2. 1/2 times -7 is -7/2. 3/2 minus 7/2 is -4/2, which simplifies to -2. So that's the same exact answer right there, -1, -2. Now, why do I have all this extra work? Well, just a reminder that if you don't memorize the inverse formula, Or if your inverse is a 3 by 3, you can use the row echelon form method to find the inverse that way. So I just used my row operations to show that I got the same inverse, whether I used the formula or the row operations. So that's just like bonus note work for doing that if you aren't going to memorize the formula. Okay, any questions?